Good morning to everyone. Myself Murali. I'm dealing with control system subject. I'm working in EEE department in BV Raju Institute of Technology. So what is the importance of control system? In our day-to-day life, we are using control system many applications from our day-to-day activities. From morning to evening, in every kind of aspect, we are using the control system topic directly or indirectly. For suppose if you take the traffic signal, in olden days the traffic signals are like timer setting devices, but nowadays the traffic signals are based on the traffic density. It is automatically controlling the traffic. So what is the innovations teaching in the control systems is in real life example, the importance of control system for electrical and electronics engineers, and by using the videos and physical models to improve the understanding of the basic components. By means in physical system means understanding the concepts of basic concepts in the MATLAB implementation to draw the various plots, practical exposure, and the continuous assessment, feedback, and for effective learning. These are the innovations in the teaching in control systems. The control system prerequisites the basic knowledge of engineering mathematics. Here, if you know the basic mathematics, we can easily get the maximum score in the control system subjects. The course objectives are obtain a working mathematical model of a control system. The second one is the perform the time domain and frequency domain analysis for model predict system behaviors. And the third one is the represents the analysis of control system in space. So these are the course objectives. The course contents are the unit 1 is the system components and their representations. In the second chapter, the time response of dynamical systems. In the third chapter, the concepts of stability analysis. In the fourth chapter, the frequency response analysis and system analysis. In the fifth chapter, the control system analysis using state space model. The overview we can analyze in the one chart, that is a mind map of the control system. In the first chapter, we can determine the transfer function by using the mechanical system or electrical system, or by using the different methods, mechanical to electrical conversion system or signal flow graph. Any method, we are determining the transfer function. In the second chapter, we are analyzing the time response analysis. So we can see the time response of dynamical model. So that will be covered in the first chapter, the motivation and examples of control system, effects of feedback on control system, the overall gain, sensitivity and stability, and mathematical modeling. The mathematical modeling for electrical system as well as mechanical system, and combined electromechanical system also covered. For these different mechanical system and electrical system, we are determining the transfer functions. So one is from mechanical modeling, we can determine the transfer function. From block diagram also, we can determine the transfer function of the system, any kind of system. So in this block diagram, we can use the Motion gain formula. Then we can determine the transfer function. The next topic is the transfer function of DC servo motor. Then the numerical problems covered in the first chapter. So overview we can cover this definition of the problem and from the system. In the second chapter, the time response analysis of dynamical systems. In the first chapter, we are getting some output like transfer function. In the first chapter, we are determining only transfer function determination. In the remaining chapter, we are applied the transfer function. We can determine the response of the system or stability of the system or the behavior of the system. In the second chapter, the time response, transient response and steady state response, measures of performance of standard first order, second order system. So for first order, second order system, we are determining the steady state response as well as transient response. So without knowing the steady state response and transient response, the component is not introduced in the market. Actually, the steady state response is the constant output we are getting, then the system is said to be the steady state response. If the any fluctuations or any disturbance occurs in the output response, then it is said to be transient response. If the system having the high transient response, by using the different controllers or compensators, we can reduce the transient response of the system. So next one is the error analysis. So what is the steady state error and how to determine the static error constants and numerical problem. If the steady state error value will be high, then what is the impact of the system? If the steady state error value is less, then what is the impact of the system? We can determine in the error analysis. Based on this error, then we can apply in the real-time applications. Then the last one is the controllers response of the P, PD, PI and PID controllers. Actually, any kind of system, if we are not getting the desired output, then we are using some controllers techniques. These controllers having to utilize to reach the maximum or desired output. For suppose if the steady state response, transient response is very high, so then we are using the controllers then reduce the transient response. Not only for transient response, for the obtaining the accurate outputs, we are using the controllers. Next one is the stability analysis. So in the first chapter, we are determining the transfer function. For that, the system is said to be good or bad, or indirectly directly we are saying the system is performing the better performance or not. By using the stability concept, we can determine. In the stability concept, first we observe bounded input, bounded output. So then what is the behavior of the system? Means if the bounded input apply, then what is the response? If the output is in the bounded condition, then the system is said to be the stable condition. For this purpose, we are applying the root stability criterion and relative stability. Relative stability means root locus concept. We are applying, and in the root locus concept, we sketch the root locus, and for that we are simplifying the problems. In the third chapter, majorly the two topics are there. One is the root stability criterion, second one is the root locus technique. This is one topic, this is another topic. These two topics will be major focus in the third chapter. These two topics to determine the stability of this system. The fourth chapter is covered frequency response and system analysis. So for suppose generally 2 by 2 equation is there. For suppose 2x plus 3y equal to 4, 4x plus 5y equal to 7. How many ways we can determine the solution of the x and y values? By using the trial and error method, by using the equation simplification method, by using the equation simplification method, by using the equal values covering in the first and second equation, multiplication factor in the first equation and multiplication factor in the second equation, then simplify, we will get the x and values. We can do solving the 2 by 2 equation. There is a many number of methods are there. Similarly, for a transfer function, we can determine the different methods. We seen one is the root stability criterion and the root locus. Then another methods we can use by using that is one is Bode plot, and second one is next one is a polar plot and Nyquist plot. These three also to determine the system stability only. These other methods also using for the system stability only. Bode plot, polar plot and Nyquist plot. These are the determined. Before determining the stability, we can find the gain margin and phase margin. So these are the frequency domain specifications. The frequency by if the bandwidth will be low, how the impact on the system. If the bandwidth will be less, how the impact of the system we can determine here. The frequency domain specifications. So then the compensator. So compensators we have three there. One is the lead lag compensator. These three compensator we can use to determine the highest to maximum output. Otherwise we can say for accurate output we can use the compensators. Compensator means for suppose if a person unable to see on board particularly, then we can use we can determine the sight of the person, then we can the doctor suggest based on this sight glasses, then you can easily watch the any screen. Similarly, if the system is not working properly, we can suggest some compensator, then we can get the accurate output by using the different compensators. So this is only for elementary treatment only, not in depth. Okay, the last chapter is the control system analysis using state variable methods. In this third chapter and fourth chapter, we apply root stability criterion, root locus, and Bode plot, polar plot, Nyquist plot. But in mathematical way, we can simplify by using the state variable of the transfer function. By means, in these two chapters, some limitations are there, but in the fifth chapter, for any kind of system, we can apply the state variable methods by for means a linear system or non-linear system or time invariant system or time variant system, any kind of system, we can apply the state variable models. Then we can simplify and then we can get the state equation. Based on the state equation, we can determine the controllability and observability. Finally, we get the system performance. The last one is the state transition matrix and its properties. Then numerical problems. These are the topics covered in the fifth chapter. The overview will be covered here. In the first chapter, the definition of the problem and form the system. Here, indirectly, we can determine the transfer function. In the second chapter, we can observe the time response of dynamical system. Okay, so time response analysis. Here we can analysis. This is the second chapter. This is also covered in the second chapter. Okay, so in the third chapter, concept of stability analysis, root locus stability criterion, root locus stability criterion. That is the one is the root locus. Okay, so next one is a Bode plot, polar plot, and Nyquist plot. These are the covered in the frequency analysis. In the frequency analysis, we can see the root locus, Bode plot, polar plot. So these are the third chapter topic. Okay, these are the fourth chapter topic. These are stability. Stability is covered in the fourth chapter as well as fifth chapter. Stability covered in the third, fourth, fifth, totally related to stability criterion only. Okay, so this is a total system we can cover. In the student engagement, we are using the real-time examples. So videos and physical models and MATLAB implementation. Some are the students having doubts. Sir, if we are designing some model, it is really implemented in practical or not. First of all, we can implement in the MATLAB. If it is working, then we can implement in the practical system. So the control system topic we can use in the satellite communication, and in any concept we can cover. That's why it is common for EEE, ECE and BMA students. For three branches, the subject will be covered. Okay, so these are the course outcomes. These are the 5 course outcomes. So one is the first one, based on the chapters we have decided the outcomes of the subject. First one is the describe the importance of control system and determine the transfer function of the system. Or using various methods. Various methods means for electrical system or mechanical system, or by using the Masson gain formula. For any kind of system, we are determining the transfer function. This is a key point here. So in the second chapter, the analysis of transient and steady state response of first order and second order system. So this analyze the transient and steady state response. Okay, so in the third chapter, investigate the stability of control system by using root stability, Hurwitz criterion and root locus. These two methods we are using for determine the stability. So in the fourth chapter, examine the system by using the frequency methods to determine the stability margins. The stability margin means phase margin and gain margin. So what are the different frequency specification method? One is the Bode plot, second one is the polar plot, third one is the Nyquist plot. These 3 plots we can determine the stability margins. In the fifth chapter, the state space model and block diagram for state equations. For any kind of system, we are implement the state space model. For linear control system, non-linear, time variant, for any kind of system, we can implement the system and we can determine the stability. So this is the overview of the control system. So thank you.
like, share and subscribe. Hit the bell icon for more updates.